So now that we've talked about electron configurations, I want to show you how to use the periodic table to write electron configurations. So here we have the periodic table, and as you'll see, we've got S, P, D, and F. So these are the orbitals and how they're organized on the periodic table. So all of your S orbitals are found here, and when you put electrons in your P orbitals, you find it here. D orbitals and F orbitals. So here's another way of looking at that. So when you put your electrons in the first energy level, they go to the 1s orbital. And so that's your hydrogen and helium. And then you put electrons in your 2s, then in your 2p, then in your 3s, 3p, 4s, 3d, 4p, 5s, 4d, and so on, until you get your electrons all the way in. Now notice after you put them in your 6s, then you put them in your 4f, and then you go back to 5d, then 6p, then 7s, then back down here, and through. And so we can use then the periodic table as a way of quickly writing electron configurations. So let's do the electron configuration for arsenic here. So here we can see arsenic, and it has 33 protons. So the electron configuration of the neutral arsenic atom would then also have 33 electrons. So we can find arsenic here on our periodic table. And we've got it right here. And we're going to figure out what is its electron configuration. So to do that, we're going to start right up here with hydrogen. We know that hydrogen is the 1s energy level. And helium is also the 1s energy level. So hydrogen has 1 electron there, helium has 2. And then we go to the 2s, and it has 1, 2, and then it is full. Then we're going to go to the 2p, and in the 2p we've got 6 of them. So I went ahead and filled that in, and we've got 1, 2, 3, 4, 5, 6 electrons can fit in our p. And then we go to the 3s, put 1 electron here, 2 electrons. Then we go to the 3p, and I went ahead and filled that out so you can see that there's a total of 6 electrons that can fit in the 3p. So now let's start writing this down so you can see we've got 1s, we put 2 electrons in there, and we got our 2s, we put 2 electrons in there, so that's 4 electrons. We've got our 6p electrons in our 2p, so that's a total of 10 electrons, 2 plus 2 plus 6. And then we've got 2 electrons in our 3s, so that's 2 more, there are 12 electrons. 6 more electrons in our 3p, so that brings us up to a total of 18 electrons. And now we're going to go to our 4s, and we can put our 2 electrons in there. So we've got 20 electrons. And then we've got our 3d in this section here. So we can go ahead and put those electrons in, and you'll see that the d orbitals can hold a maximum of 10 electrons. And then we get to the 4p, and that's where we'll put the next set of electrons. But before we get there, let's put our 3d up here. Let's double check. So we've got 2 plus 2 plus 6 is 10, plus 2 plus 6 plus 2 is 10 more, plus 10. So that brings us to a total of 30 electrons. And we want to put in 33. So we have 3 more electrons to put in. So we're at our 4p. We're going to put 1, 4p, 2, 4p, 3. And so right here, this is arsenic, and that is a total of 33 electrons. And we put in the 4p3. So this is arsenic's electron configuration written out. And we've got 33 total electrons there. So now let's look at calcium here. It's got 20 protons, so it would have 20 electrons. And let's see what its electron configuration would be. Okay, so let's walk through and do the electron configuration for calcium. So first we're going to start with the 1s, and we know that it's full. So 1s, 2. Then we're going to go to the 2s. We're going to fill that up all the way, so we're at 2s2. We've got a total of 4 electrons. We're going to get to 20. Now we're going to go to the 2p, and p's can hold a maximum of 6, so that gives us 4 plus 6, or 10. And then that's full, so we go to the 3s. We're going to fill that up with 2 electrons. And now that that's full, we have 12 electrons. So we go over to the 3p, and we're going to add 6 more electrons. So 3p, plus 6 electrons in there. So you can see we've got 10 here, and 2 plus 6, that gives us 18 electrons. We have room for 2 more if we want to get 20. And so we go to the 4s, and we put the last 2 electrons in there. And if you add all of these up, then you can see that that gives you a sum total of 20 electrons.